Okay, so we're going to start or continue 2.7, and we left off with an example or an exercise where f of x was x squared minus 2 and g of x was x plus 5, and we want to compute g composed with f of x. So how do we do this? Well, this is g of f of x, which is f of x plus 5. And so we have x squared minus 2 plus 5, which is x squared plus 3. So that's g composed with f. So if you wanted to compute g of f of 2, you'd have 2 squared plus 3, which is 4 plus 3, which is 7. On the other hand, if you wanted to do f of g of 2, well, this is f of g of 2. We'll do this just a slightly different way. Instead of computing the general f of g of x, let's just compute g of 2 first. So g of 2 is 2 plus 5, which is 7. And what we need then is f of 7. And f of 7 is 7 squared minus 2, which is 49 minus 2, which is 47. Okay, so that was the exercise from last time. Let's do another example that's just a bit different. So suppose we have a function h where h of negative 2 is 6, k of 6 is minus 4, and k of 3 is minus 2. And we want to compute two things. We want to compute h of k, h composed with k of 3. And we also want to compute k composed with h of minus 2. How would we do this? Well, this is h of k of 3 for 1, which is h of negative 2, which is given to us as 6. So that's the first one. Similarly, on the other one, k composed with h is k of h of negative 2. Well, h of negative 2 we know is 6, so this is k of 6, and k of 6 is minus 4. So you can also, if you have enough information, you can compute some composition values directly without knowing the whole function. Okay, so there's a general question that we have to now answer, which is if you're given f of x and g of x, what is the domain of f composed with g of x? So this is kind of an important question, and it's a little bit subtle. So first off, how do we get to f of x? Well, f of g of x? Well, we start off with x. We take x and we plug that into g of x. That's the first stage of doing the composition. Then we take g of x. So this is kind of like inputting into the machine g. Then we take that and we input into the machine f. So you take f of what you got from g, and that's the composition, f of g of x. So we know for sure right here, if this is going to work out, x must be in the domain of g to start with. So no matter what we have, we're definitely going to need x to be in the domain of g, because that's the first stage of doing the composition. The second stage takes g of x and plugging into f. Well, that requires g of x to be in the domain of f. And those two conditions together define the domain overall. So now definition, or I don't know, let's just call it a result, I guess. Just by this sort of straightforward analysis, the domain of the composition of f and g, this is the set of all x where, so set of all x such that x is in the domain of g and g of x is in the domain of f. That's literally what we want. We want x to be in the domain of g, and we also want g to be in the domain of f. So, well, let's do an example. That way it should become a little bit clearer. So let's do an example here. Let's say f of x is x squared, and g of x is the square root of 2x minus 8. Now notice, to find the domain of the composition, we need to know the domains of both f and g. So let's first find the domains of f and g. Well, this is just a polynomial for f, and remember that for all polynomials, our domain is simply all real numbers. For g here, we have a square root, and anytime we have a square root, we require whatever is inside the square root to be at least 0. So we have 2x at least 8, so x has to be greater than or equal to 4. So the domain of g is 4 to infinity. Okay, let's go ahead and let's compute f composed with g explicitly, and then we'll find the domain. So let's find f composed with g of x. This is f of g of x. So we replace x with g of x, and we get this. And this is now the square root of 2x minus 8, quantity squared, which is simply 2x minus 8. Now, here's what things get potentially a little confusing, is that if you just look at this guy, 2x minus 8, so on its own, let me put this as a separate comment, on its own, if we had a function, say h of x being 2x minus 8, the domain of h would be all real numbers because it's just a polynomial. It's a line. But the problem is, unfortunately, this is not the case. This is not the case for f composed with g. Okay, the domain of f composed with g is not all real numbers. Now again, why is that? I'm going to reiterate, because x first has to go into the function square root of 2x minus 8, and then it gets squared by f. Okay, so this is the process of going to g. This is the process of going to f. Well, so remember, for starters, x has to be in the domain of g. Well, that means, what was the domain of g? It was 4 to positive infinity. So for sure, the domain of f composed with g, it's going to be contained inside this set. It's going to be contained inside this set because we have still an additional condition. We need whatever g of x is, that needs to go into f of x. But luckily, so remember, the domain of f was all real numbers. So the domain, being in the domain of f, every number is in the domain of f, so we don't have to worry no matter what output g of x comes out with. So no matter what g of x is, because it's going to be a real number, it's in the domain of f. It's in the domain of f. So hence, there's no additional conditions come from the second part. So let me rewrite this. So the domain overall of f composed with g, this is all x, where x is in the domain of g, and g of x is in the domain of f. So what happens is, because the domain of f here is everything, every g of x will satisfy. This is automatically satisfied. Automatically satisfied as the domain of f is all real numbers. It's everything. So in this particular case, the domain of f composed with g is just all x, where x is in the domain of g, which means it's exactly the domain of g. So it turns out in this case, it's exactly 4 to infinity. Okay. No matter what, it's going to be contained in the domain of g. In this case, it's exactly the domain of g because we don't get any additional restrictions from the second part. Okay. So we found the domain, and the domain turned out to be exactly the domain of g. Now let me leave you guys here with a little exercise that's just a bit different. It has a little bit of restriction on f. So suppose f of x is 1 over x squared, and g of x is the square root of 9 minus x. And what I want you to do is two things. So first of all, compute the expression f composed with g of x. What does that actually equal as an expression in x? And then find the domain of f composed with g. And here, just a little note, the domain of f does have some restriction, right? X squared can't be 0 because that's in the denominator. So there is a little bit of restriction on the domain of f. It's not a big one. So it's just similar to the one we did. There's just one little step more. So try that out, and in the next video, we will go ahead and do that exercise.